Lesson 5, magnitude, position, and zero or non-vector. Magnitude of a vector. The magnitude of a vector A, sometimes called the modulus of the vector, is represented or denoted as this. You have two straight lines, symbol of determinant or absolute value. Then the vector A is inside. In general, if vector A is given as a column vector with the entries S and Y, then the magnitude of vector A is defined as the magnitude of vector A equal to square root of sum of squares of the various components, that is s squared plus y squared. Notice that the magnitude of a vector is always given as a positive number or units. We have position vector. In the figure below, H is a point SY on the Cartesian plane. The origin is point O. Vector A is the displacement of H from O, moving from O to H. Since this displacement gives the position of H relative to the origin, vector A is called the position vector of H because the displacement is relative to the origin, then to the point H. For that reason, vector A is called the position vector of H. In figure 16, vector A is equal to vector OH and is equal to the column vector with the entries S and Y. Hence, if a point has coordinates S, Y, its position vector is a column vector. Zero or non-vector. The zero vector is a vector with a magnitude of 0. The zero vector has no particular direction. It is denoted by 0. The zero vector is sometimes called a non-vector. Consider the figure below, figure 17. We have the vector from P to Q. From these two arrows, it means that you can move from P to Q and from Q to P. Actually, there is no fixed direction. It can be from any point. A vector that appears in this form is called the zero or non-vector. Considering figure 17, let's write out vector PQ. It is equal to the column vector with the entries 5 minus 4. This is what happened. The first number is obtained from the S-axis. From here, you have 1. Here is 6. When you subtract 6 minus 1, you have 5. The second number is from the y-axis. From here you have 2, then here is 6. You subtract the first point and second point. So 2 minus 6, you have minus 4. And QP becomes this column vector. Now we want to add PQ to QP. When you carry out the addition, you have the 0 vector. The magnitude of the vector sum is 0. Remember, magnitude is the square root of 0 square plus 0 square. That is square root of 0 equal to 0. If we do the same thing considering arrow S and S arrow, we have these vectors. If you take their addition, it is also equal to the 0 vector, and their magnitude is equal to 0. The vector sums PQ plus QP and arrow S plus S arrow are called 0 or non-vectors because their respective magnitude is 0. Examples: find the magnitudes of the following vectors. 11, you have this column vector. Solution: let's give the vector a name. So you have let vector A be equal to the given column vector. The magnitude of vector A is simply equal to square root of the sum of squares of the components. That is square root of minus 5 square plus minus 12 square. That is square root of 25 plus 144. You have square root of 169, and that is 13. Number 12, you have this column vector. Let vector B be equal to the given column vector. The magnitude of vector B is simply square root of 0 square plus 7 square. That is square root of 0 plus 49 equal to square root of 49, and that is 7. Example 13. If vector AB is the addition of the two column vectors, find the magnitude of vector AB. Solution: from the given problem, you simply add the two column vectors and you have the column vector with the entries or elements 9, 12. Therefore, magnitude of vector AB is equal to square root of 9 square plus 12 square, and that is equal to square root of 81 plus 144. You have square root of 225 equal to 15. Example 14. If this column vector minus vector Q is equal to this column vector, find the vector Q and hence find the magnitude of Q. Solution: in the given equation, you simply solve for vector Q. Vector Q needs to be positive. To achieve that, you transfer minus vector Q to the right. It becomes positive, and you transfer this column vector to the left, it becomes negative. Therefore, vector q is equal to minus 3 minus 8. That is minus 3 plus 8 equal to 5. 1 minus 4 is equal to minus 3. This is vector q. The magnitude of vector q becomes square root of 5 square plus minus 3 square. That is square root of 25 plus 9. You have square root of 34. End of lesson 5. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.